An electric generator is a device that converts mechanical energy to electrical energy. We use generators to function. Electric generators are used to efficiently convert mechanical energy to electrical energy. Magnetism is the basis of their principles of operation. They use permanent magnets, electromagnets, and exploit the magnetic properties of material.
There are two basic types of generators, DC generators and AC generators. In this video, we will demonstrate how to build a simple generator. You will need the following materials for this project. Considering you follow our instructions exactly without any omissions or revisions, this task should take you roughly 2 days to complete.
First, we must make the hollow-ended box. To do so, score a cardboard strip with the following measurements. Next, fold it securely like this, and securely tape the two free ends, forming the hollow-ended box.
Using a ruler, draw 2 lines diagonal on the face of the box, forming an X as shown. Then using a nail, poke a hole perfectly straight through the center of the box, going through both sides and both layers of the cardboard. Then pull the nail out and use it to widen both holes slightly. So when you put the nail back through, it will be loose enough to spin freely. You may also replace the nail with a steel rod approximately 5 inches long as we did, because it is more light in terms of weight, so it spins more freely.
Next, put a pair of ceramic magnets on either end of the nail, in the hollow cardboard box as you can see. Give it a spin. This guarantees that the box is large enough to allow the magnets to rotate freely. If you are experiencing difficulty with getting the magnets to remain secure, you may use a Dremel to put a groove in the center of one of the magnets, the same width of the steel rod.
Using the spool of 30 gauge copper wire, tape one end of the wire to a side of the box, then wind it around, making sure not to wind over the exposed ends. Do this at least 300 times, making sure to wrap around the steel rod, and evenly distributing strands of copper on either side of the steel rod.
Then, as demonstrated, use sandpaper to scrape the thin plastic coating off 2 centimeters of the wire ends. Make sure that each end of the generator's wires are totally cleared of the red plastic coating. Twist the scraped end of each generator wire securely around the silver tip of each wire from the 1.5 volt bulb.
Using the ends of the steel rod, spin rapidly and the light bulb should light dimly. If your light bulb doesn't work, try spinning it in a dark room as we did, so that you don't miss the dim glow. All metals contain a movable substance called electric charge. After all, the atoms of the metal are made half of positive protons and half of negative electrons. Metals are special because their electrons don't stay connected to the metal atoms. Instead, they fly around inside the metal and form a type of electric liquid inside the wires. The fluid charge is movable, and this lets metal be electric conductor.
When a circle of wire surrounds a magnetic field and the magnetic field then changes, a circular pressure called voltage appears. The faster the magnetic field changes, the larger the voltage becomes. This circular voltage tries to force the movable charges in the wire to rotate around the circle. In other words, moving magnets cause changing magnetic fields which try to create electric current in closed circles of wire. A moving magnet causes a pumping action. If the circuit is complete or closed, then the magnet's pumping action can force the electrons of the coil to begin flowing. A moving magnet can create an electric current in a closed circuit. The effect is called electromagnetic induction. This is a basic law of physics, and it is used by all coil electric generators.
Now, in regard to the light bulb, the 1.5 volt bulb acts as a medium in which the electric current can pass through. When the charges within the copper wire pass into light bulb's filament, their speed greatly increases. Inside the narrow filament, the fast-moving charges heat the metal by an action resembling that of an electrical form of friction. The friction becomes so high that the metal filament glows. To sum up, the faster you spin the magnet, the higher the voltage pump force becomes, and the brighter the light bulb lights up.
There are many types of generators, such as those that produce hydroelectric power and wind power. If you would like to take your generator a step further, continue watching as we will create a model that resembles that of both a hydroelectric dam and wind turbine. First, drill a hole 4/5 of the way up a container similar to the one shown. For this experiment, we used a 5/8 drill bit to coincide with the diameter of our steel rod. You may use one that best suits whichever steel rod you chose to use.
Next, insert one end of your steel rod through the hole that you just drilled. You will notice that the generator is unstable and needs to be held. Hold the generator so that the steel rod is perpendicular to the ground. Then, place a piece of wood 8 cm by 3.5 cm underneath the generator. This will serve as its base. Then mark a dot on the center of the piece of wood as well as the container. Drill a hole directly through the piece of wood and container. In this case, we used a 5/8 drill bit again. Attach the base to the container by inserting a nut through the hole and securing it with a bolt. Please note that in our model we used 2 pieces of wood that together have the same measurements to compensate for a lack of wood with those specific dimensions. If you face the same problem, you may do the same.
Next, get a thin piece of wood that's length surpasses the height of your generator. In this case, we use a 7" by 1/5 inch. Prop it up against your generator and mark where the steel rod comes in contact with the piece of wood when positioned perpendicular to one another. There, drill a hole through the piece of wood and insert the steel rod through the hole. Secure the piece of wood by taping it to the bottom of the container continuously. We wrapped it approximately 5 times. Next, using wire cutters, cut the spoon handle, leaving a 1 cm stem on the bowl of the spoon. Repeat this 3 more times and put aside.
Draw an X on the circular face of a wooden dowel measured 4 cm in length and with a diameter of 2.5 cm. Create slits in the dowel by sawing over the marked lines. Then insert each of the 4 spoons into the wooden dowel by placing one in each slit. To secure, glue them in place using a hot glue gun. Drill a hole through the circular face of the wooden dowel. The drill bit that you use should be one less than that of the one used to drill a hole through the container. To insert the steel rod. This is because the hole was slightly wider than that of the steel rod. To allow it to rotate freely, by making it slightly smaller, the wooden dowel will be secure once attached to the end of the steel rod that was inserted into the container.
Before securing the wooden dowel in place, slip a washer and then an O-ring around the end of the steel rod that is within the container until it is up against the inner wall. Next, insert the same end of the steel rod into the hole of the wooden dowel. Apply pressure with your hands and use a clamp if you can to secure the wooden dowel in place. Then drill a small hole in the wooden dowel until you reach the steel rod and screw it in place. Now, in order to drain out the water, drill several holes into the side of the container 1/3 of the way up. When performing the hydro dam part of the experiment, be sure to cover up the generator with something to prevent it from being sprayed with water. If too much water comes in contact with the copper wire, the light bulb will not light. We used a clear plastic container and cut slits into it to attach to the side of the white container. Ultimately, when the water from a hose with fairly high pressure is directed on an angle towards the bowl of the spoon turbine, the high pressure exerted by the water spins the turbine, which generates electricity similar to that of a simple generator. The same result occurs when air with high pressure is exerted on the bowl of the spoons or turbine. Both instances have the same result, but replicate both hydroelectricity and wind power respectively. Whether it is high-pressured water simulating that of a hydroelectric dam or compressed air simulating that of a wind turbine, our model demonstrates that the driving force spins the turbine, which generates a magnetic field in which the magnet's flow of electrons is created in the coils of the stator, thus producing electricity. By having made the simple generator and taking it a step further, producing a dual generator that mimics both hydroelectricity and wind power, it is easy to make real-life connections between a simple physics project and the electricity that powers our homes on a daily basis.